Okay, so for the second problem, I have decided to illustrate the alternative way to solving it. A couple of you saw that you could actually try this in a visual approach, but I've seen that some of you haven't taken it all the way through. So you kind of like indicated that you wanted to solve this using the visual approach, but somehow got stuck somewhere and couldn't conclude this thing. So I wanted to illustrate that you could actually solve the second problem from the optional test that we wrote on Thursday and Friday to indicate that you can actually solve it using the visual approach. And there are those of you who somehow got the right values using the visual approach without demonstrating how you actually arrived at them. So I wanted to just fill up that space to show how you can actually go about doing that. So the problem we had the force FAC that was with a constant magnitude of 1,000, and we had a force of FAB, which was unknown, but it had a constant angle, which was given as 40 degrees. Then we had a force that was going down, and you were required to find that force as a maximum. So how I propose that we get to solve this is using the visual approach. We can think of it as resolving these two forces of 1,000 and the unknown one at 40 degrees, resolving them and finding the resultant that is basically going to now be a resultant going upward. Excuse my lines, I'm using my mouse so they don't actually look nice. But yeah, you have a resultant that you resolve from these two forces and the resultant will be going upward. Now, if you consider this resultant, we can use the previous maximum, minimum conditions that we worked with when we were resolving vectors to find, say, one vector that is observed by varying other vectors. So we can do that and find this resultant as a maximum and equate it to the force F, because remember, these two forces that are going upward, when they sum up, they give us a resultant that will then have to be in equilibrium with the force F going down. So whatever maximum we calculate from this force should be the same as with the other force that is going downward. So to do that, I want you to now think of the force that we have shown in green going to the left as the force FAC, and the one in blue going upward as FAB. And obviously the resultant will lie along the vertical, because you have seen that the force F is lying along the vertical. So it will lie along the vertical, in this case going upward. So if we imagine that we have a scenario where the force FAC in green is going to the left, and added to that we have the force AB going to the right, then as I'm repeating, the resultant will lie in the vertical direction. And this is one of the scenarios where we can have a solution. Now, the force FAC, because it has a constant magnitude of 1,000, can vary by angle. And when it varies by angle, it'll kind of like act like a radius that can vary from a single point and touching to various points that almost form a circle, as indicated in the sketch. So those are the various possible locations where we can have this force FAC. And for all these positions, we note that in the first and the second quadrant, the blue line indicates the possible locations for the force FAB. And we see that in the first quadrant, the force FAB is actually facing downward, which is not exactly according to the conditions of the original problem, because we saw that the force FAB was facing upward, going in the right top direction. In the second quadrant, we have both the force FAB and the force FAC going in the correct direction. You can see the blue lines going upward in the top direction, and we expect that all of them are meeting a vertical line right there in the middle, which is where we expect the resultant to lie. If we continue and observe what happens in quadrant 3, we see that the force FAC is now facing downward, which is not exactly according to how the problem was. Same with the fourth quadrant, we see both the force FAC and FAB going downward. So we can conclude that the fourth and the third quadrant are not going to yield a scenario where we have our actual result. Therefore, we're going to work just with the second quadrant. Now, from the second quadrant, if we sum up the two forces FAC and FAB, we are likely to get a resultant that is shown with a red line that is going upward. And you can see a small one that is now basically going from here to there, showing where the resultant can lie. Now, if we go and look at different scenarios, if the force FAC is basically lying along the x-axis in that direction, and the force FAB is lying in this particular direction as indicated there, then we can see that we're going to get the resultant basically forming along there. Okay, and by the same token, if the force FAC is shown going in this particular direction at some angle, then we're going to have the force FAB being that one there that is already located. It will generate a resultant that goes from the center to where it's indicated as a red line. If we now move to the next set of forces that are adding up, in this case, we're looking at this particular force here that is indicated going up, and it's adding up with the force FAB that is going at an angle of 40 degrees. We can see that somehow the resultant has gone up a little bit. But what I need you to note is the fact that when we have the force FAB and the force FAC being such that the force FAB is tangential, and by tangential I mean that at this location here, that's where it is tangential. So if you imagine it now being tangential, then I will put it to you that that's where you're going to more likely have the maximum force for your resultant, which is already indicated in the red line there. That's where the largest point will lie. Put differently, if we resketch this, what I am saying is that the force FAC shown in green going to the left top section, summed up with the force FAB shown in blue going to the top right, they will yield a resultant that is the largest. And this happens when the two forces FAC and FAB are perpendicular to each other. Because when the force FAB is tangential, that's precisely what happens for it with respect to the force FAC. And from there, we already know that the force FAB is always taking place at a constant angle of 40 degrees. And furthermore, we know that the force FAB is measured as theta at an angle of theta with respect to the horizontal. And from this, we can conclude that the angle theta would have to be 50 degrees for us to get the maximum resultant shown in red, which is exactly the result that we wanted. And that just concludes how you would solve the second problem. As you can see, there's more than one way to skin a cat, as I keep saying. So all that was necessary for those of you who are tempted to do this in the visual approach was just to take it to a logical conclusion, following a systematic way of varying one vector in order to observe the one that you want to see become maximum by creating different scenarios of your vector additions. Thank you.